Hey everyone, it's Justin again. In the last video, we explained what makes inequalities different from equations. So now we just need to learn how to solve them. Which would you prefer? Having $1 or having $2? You prefer $2, right? More money in your wallet's always better. But what if we multiply everything by -1? Now what's better? Owing $1 or owing $2? Owing $1 is better because you'll have more money left over afterwards. When we flip the value of everything in an inequality, the order also flips. So what was previously higher is now lower. This will be important to remember as we start solving the inequalities. If we multiply or divide by a negative, which will flip all the positives and negatives, we also need to flip the inequality symbol. So we know how we would solve this if it was an equation. We cancel the variables from one side, and then the constants from the other side, and then we divide by 24, and we get that x equals 2. But what if, instead of an equation, it was an inequality? Solving inequalities is almost the same as solving equations. We just have to be careful with the sign. Let me show you what I mean. Just like when it was an equation, we add 16x to both sides, add 16 to both sides, and divide by 24. Be careful how you read this answer. Remember, the alligator is always hungry, so this says that 2 is less than x. Unlike with equations, it's much easier to read inequalities if the variable is on the left. So we're going to flip it so it says x is greater than 2. It means the same thing, that x is bigger and 2 is smaller, but it's a little easier to understand when you read it like this. Any number bigger than 2 will work, so let's test it out. We need to use a number bigger than 2. We could pick any number, but I'll just use 3. So -16 times 3 is -48, plus 32 is -16. 8 times 3 is 24, minus 16 is 8. So we get -16 is less than 8, which is true. So using a number bigger than 2 worked. Now let's talk about a few other ways the less than or greater than symbol can cause some issues if we're not careful. First, since the sides actually matter in an inequality, what happens if we change which side the variable and the constant end up on? So if we subtract 8x to get it off the right, and then subtract 32 to take that off the left, then we get that -24x is less than -48. We divide by a -24 and get that x is less than 2. Wait, that can't be right. We solved the exact same problem a minute ago, and it said that x has to be greater than 2. Well, what's going on here? The key is that last step when we divided by a negative number. Remember what we said at the beginning of the video. If you multiply or divide the whole problem by a negative, it'll also flip the inequality symbol around. So when we divided by a negative, the sign should have flipped, giving us the correct answer of x being greater than 2. Next, let's try this one. Previously, we wanted the left side to be less than the right side, but now we flipped the sign so that the left side is bigger. How's that going to change our answer? Well, let's see. Let's do the same thing that we did before. Add 16x to both sides. Add 16 to both sides. Divide by 24. And we get that x is less than 2, rather than x greater than 2 than we got before. Did we make a mistake again? No, of course not. The reason it's different is because we changed the problem. By changing which side of the problem is bigger, it changed which side and the answer had to be bigger. So let's try it out. We can use any number smaller than 2. We could use 1, or we could use any negative number. But you know what I think? Whenever possible, use 0. It makes every operation so much easier when you're checking your work. Anything times 0 is automatically 0, so the x terms cancel out, and we just get that 32 is greater than -16. And that's true. So using 0 or any number less than 2 seems to work here. You're doing great. In the next video, we're going to be going over a few more examples of how to solve inequalities.